Hi guys, hello everyone. How are you? Uh, Today, in this video, we are going to discuss about the problem continuation of JEE advanced equilibrium problems. See, it is very similar to the problem we have discussed in the previous video. It was given in 1993. That is for 3 marks question. The same, almost very similar question has been repeated here. In that case, some metal bromide they have given, but here it is zinc sulfide. Directly they have mentioned. You can see the compound is given as zinc sulfide. You can observe this. Okay. An acidified solution of 0.05 molar Zn plus 2 is saturated with 0.1 molar H2S. What is the minimum molar concentration? What they are asking? What is the minimum molar concentration of H plus is required? H plus is required to prevent the precipitation of zinc sulfide. Okay, that means we have asked what we have to find the maximum concentration of sulfide ion we have to find out. Okay, let us go through. Right? Yes, it's very similar. And with respect to H2S, saturated with what? 0.1 molar H2S. Okay, yeah. Let us go through the solution of this. It was given in advanced 2020. Let us go through this. You see, all of you. Okay, all right. Zns solid gives rise to what? Zn plus 2 aqueous plus S minus 2 aqueous. Okay, it has to be precipitated. What has to be precipitated? Sulfide and zinc plus 2 and sulfide must be precipitated as Zns. In order to do that, what we have to find out the sulfide ion concentration. To prevent the precipitation, we have to find out first. Okay, in order to, yes, let us go through here. I am writing the sulfide ion concentration Zn plus 2 into S minus 2. I am writing here in terms of Ksp. Okay, let us go through. Ksp is equal to Zn plus 2 into S minus 2, sulfide and zinc. You can write like that. Okay, alright. Now here Ksp value is given. What is the Ksp value? 1.25 into 10 power minus 22 is given already. You can observe that. Okay, is that clear? Right. That is equal to what here? Zn plus 2 is given. How much? Zn plus 2? 0.05 molar into the sulfide ion concentration. It is actually maximum to you have to find out. Yeah. Then what we can write? It can be written as concentration of S minus 2 is equal to, you see, okay, yeah, don't confuse, it's maximum, required maximum, you can, yeah, now it can be written as 1.25 into 10 power minus 22 by 0.05, you can see that. Okay, what it becomes? 5 2s are 10 because decimals are cancelled out. 5 2s are 10. Okay, 5 5s are 25. 25 5s are 125. You can see here 2.5 into 10 power minus 21. 25 into 10 power minus 22 becomes what? 2.5 into 10 power minus 21. It becomes. Okay, right. Now here it becomes what? You can see that here the value here we are going to write sulfide concentration is 2.5 into 10 power minus 8, but here K net is given. K net for what here? The K net for H2S. We are going to write K net of H2S is equal to concentration. I am writing one more step for the betterment. H2S gives rise to 2H plus S minus 2. You can see here. Okay, is that clear? Right. It can be written as what? It can be written as K net is equal to K1 into K2 because it's a dibasic acid. Which one is this? Dibasic acid. That's why it's K1 into K2. Okay, right. We can say that, and that is given as H plus whole square into S minus 2 by H2S, concentration of H2S. This is the overall equation, but K net K1 into K2 is given as how much? You just see here, 10 power minus 21. 10 power minus 21, which was given in the question. Okay, right. Now from this, what we have to do? We have to substitute the value of sulfide ion, we know that, H2S we know that, and H plus we required, because they are asking about what? The question is asking about the concentration of H plus required. Therefore, you just substitute the value. H2S is given how much? 0.1 molar, and S minus 2 is what? Here we got it already. You just observe this, 2.5 into 10 power minus 21, right? And K net already we got here, 10 power minus 21. We know that very well. Okay, therefore, substituting all the values, H plus square into 2.5 into 10 power minus 21 by H2S concentration is given 0.1. Already I have shown already. Okay, is that clear? You just observe that the values equal to 10 power minus 21. Okay, yes. Now, here 10 power minus 21, 10 power minus 21, what happens? Cancelled out on both sides, we can see here. And concentration of H plus square is equal to 25. 0.1, right? So, the value of 0.1, and the sulfide ion we got it here as 2.5 into 10 power minus 21. You got it here, right? Okay. Then we can write it as what? Concentration of H plus is equal to I'm sorry, actually it must be written as what? It must be written as 21 by 25. Actually it can be H plus square is equal to 1 by 25. Decimals are cancelled out here. Both decimals are cancelled out. You can observe this, and it is concentration of H plus is 1 by 5, that equal to 0.2 molar. Therefore, the concentration of H plus required to prevent the precipitation of ZNS. That means, see, the concentration of sulfide ion required to prevent the precipitation, how much? 2.5 into 10 power minus 21 moles per liter, we can say that. Similarly, the concentration of H plus here, it is required how much? 0.2 molar. Therefore, the answer here, it is what? Reported as what here? Therefore, the answer can be written as concentration of H plus required is equal to 0.2 molar. Is the final. Okay, right. Let us go for next question. All of you see that. Okay, guys. Let us see the next question. A sample of AgCl was treated with 5 ml of 1.5 molar sodium carbonate Na2CO3 solution to give silver carbonate. Okay, Ag2CO3. The remaining solution contained 0.0026 grams of Cl minus per liter. Okay, how many grams per liter? 0.0026 grams per liter of Cl minus after the completion of reaction. Okay, it was remaining. Then calculate the solubility product of AgCl. The KSP is given as, okay, 8.2 into 10 power minus 12. This was given in 1997 for 5 marks. How many marks question it is? It was given in 1997, 5 marks question. Let us go through this. Yeah, solution for this. See, the reaction here, it has been taken place in between what and what? AgCl. Okay, 2 times of AgCl plus Na2CO3 gives Ag2CO3. Okay, Ag2CO3 plus 2 NaCl. This is the overall reaction for the given process. We can see that. Okay, alright. Now, see what happens here. The solution was remaining. Which solution was remaining? Cl minus was remaining here. They have given. But before that, what we required to find out? What is the concentration of Ag plus? We have to find out in the the carbonate concentration is given. Carbonate concentration how much here? Let us write here. You can see KSP for Ag2CO3 can be written as concentration of Ag plus whole square into CO3 minus 2. You can observe this. KSP for Ag2CO3, what you can write here? Silver, concentration of silver whole square into CO3 minus 2. We can say that. Right? Now, here we required to find out the concentration of Ag plus. Now, carbonate ion concentration is given. How much carbonate ion concentration? 1.5 molar. The carbonate ion concentration is given. Okay, and KSP also it is there, 8.2 into 10 power minus 12. Okay, let us substitute the values here. When you substitute the values in that, then the equation can be written as Ag plus, directly I am writing here, the concentration of Ag plus square is equal to KSP. I am substituting. You can rewrite the equation 8.2 into 10 power minus 12, and carbonate concentration goes down because this term comes to denominator. You can see that very well. Okay, right. This denominator, what it becomes? 1.5, and concentration of Ag plus I am writing here. Concentration of Ag plus is equal to 8.2 into 10 power minus 12 by 1.5, the overall root. You can write it. Okay, yeah. The equation here, you can write it as what? 82 by 15 into 10 power minus 6. If you remove the root, then, and 82 by 15 here it becomes what? Okay, 82 by 15 it becomes 15 5s are 75. Okay, 5.3 something we will get here. Okay, how much we will get? 5.3 something we will get here. Therefore, you can take that 5.3, then if you remove the root, overall 2.338 into 10 power minus 6 you will get. How much you will get? 2.338 10 power minus 6 you will get here. The concentration of, it's approximately can be written as 2.34 into 10 power minus 6 we can write it. How much we can write? 2.34 into 10 power minus 6. For the concentration of Ag plus we will get it here. But what they are asking, we got the concentration of Ag plus and we required to find out the concentration of Cl minus also. Cl minus is given how much here? Yeah, 0.0026 grams per liter they have given. Okay, and in order to find out concentration, what here? Per liter it is given, divided by what? Molar mass. Then you will get the concentration. Molar mass of Cl how much? 35.5. Is that clear? Are you getting my point? If you per liter they have clearly mentioned here, you can observe this. Therefore, 0.0026 grams per liter by molar mass. If you divide, then you will get the value of concentration. Okay, yes. Now let's consider here, it can be written as what? 0.026 by 355. Shall we write like that? Then it can also be written as what? I am writing here 26 by 355 into 10 power minus 3. You can write like that. 26 by 355 into 10 power minus 3, you can write it. Okay. It can be written as what? 0.0733, you can write into 10 power minus 3. Okay. I am going to write here 0.0733, 32 also it's correct, 32 into 10 power minus 3, you can write it here. Now if you write in scientific notation, we have to convert that into what? Scientific notation. Therefore it can be written as 7.33 into 10 power minus 5. Okay, if you divide this, then here, then what you will get? 0.0732 something you will get here, approximately 0.0733 you will get into 10 power minus 3. Okay, you just get it here, 33 only you can write, no need to worry about. And 7, you have to express this in scientific notation. Therefore the concentration of Cl minus, you got it 7.33. Concentration of Ag plus, how much we got it here. Now what we have to find out? Solubility product of AgCl. In order to find out solubility product of AgCl, what you can write now? Now you can say this, multiply these two. Ksp of AgCl is equal to, this is of, after this reaction, the remaining, whatever the remaining solution is there, no, that remaining solution solubility product. It is after completion of reaction, whatever the solution of Ag plus, whatever the concentration of Cl minus. The combination of these two, we have to find out the solubility product, the concentration of Ag plus and concentration of Cl minus. Then substitute the values. 2.34 into 10 power minus 6 into 7.33 into 10 power minus 5. You can write like that. Okay. Yeah. Here overall value, how much you will get here? 2 point, so you will get here 2.34 into 7.33. 2.34 into 7.33, what we will get is, you see the overall value if you find here, we can write it as 17.1 into, I am going to write here the overall, if you multiply these two values, 17.1 into 10 power minus 11, you will get it. How much you will get? If you multiply those two values, 17.1 into 10 power minus 11, again we have to express in terms of scientific notation. Therefore the value, final value, it becomes here, I am writing 1.71 into 10 power minus 10, 10 power minus 10, because here it can be written as 1.71 into 10 power minus 10. This is the final answer of Ksp. The Ksp of the remaining solution is how much in the final answer? 1.71 into 10 power minus 10. We have to keep that in mind. Okay. Yes. Thank you. Let us stop here. This is the way of solving the question. After remaining Ag plus and Cl minus, we have to find out in that manner. Thank you so much. Thank you one and all.